Okay, so we've just reviewed how an individual tableau works, and a tableau talks about one particular input form and how it gets mapped to an output. And I've told you that for every possible input form in a language, the same constraint ranking will predict patterns of outputs that share phonological properties. And that's a hypothesis about how phonological systems work, that they're coherent, that they're not just different for every single lexical item. And so, in a sense, that ranking is the language itself in the sense of phonological grammar. This ranking is basically a phonological grammar that can change between languages, but it's going to be the same for every potential word in a language and every potential output. Right? So, this is kind of a radical hypothesis, and it's one that in the end will probably end up being wrong, but it's an extremely strong hypothesis that is worth investigating because it's very restrictive. What do I mean by that? Well, we've already said that every phonological system, every phonological grammar is a productive system that can be brought to bear on a potentially infinite variety of novel forms. And we model that as a rich base that basically contains any possible phonological object as its input. Uh, and so what that means is that basically the input in every language is going to be exactly the same, right? It's going to be pretty much anything goes. So in Maori, right, it was always a system of phonological knowledge that was set up to disallow strident fricatives. Now, it might have been very hard to figure out what would happen to strident fricatives in Maori before the English arrived. But once you have this influx of English words, it becomes apparent that the Maori grammar is a productive system of knowledge that can be used to repair or map strident fricatives when they do arise in the input, even if they're never available in the native Maori vocabulary, right? So again, any potential input is something that can be handled by a language's phonology. We model that using this rich base, and that's going to be basically universal. Every language contains a productive system of phonological knowledge for mapping any potential input to an allowable output in the language. And of course, the possible candidates are also essentially anything, right? So any sequence of changes you can make to this input sheep is something that you'd want your grammar to either allow or disallow, right? We don't stipulate how phonology works by only putting some relevant candidates in this tableau. By hypothesis, basically any phonological object is a potential output for any potential phonological object that's an input. If we don't change certain things in a language, then we're going to deal with that through constraint ranking, not through restricting the outputs. So in a sense, the set of candidates is also going to be the same in every language. It's going to be basically anything goes. So the input, anything goes. The output, anything goes. And then the strong optimality theory hypothesis is that actually the constraints that exist are the same in every language as well, right? So constraints that preserve features like continuant or coronal or strident exist in every language. They can be prioritized differently, but they're always there. And in fact, we think even constraints like don't have strident sounds also could exist in every language. Right? They'd just be lower prioritized in some languages. And so actually the input, the outputs, and the constraints themselves are all going to be universal within a strong optimality theory framework. In fact, the only thing that's going to be different is the ranking of constraints across languages. Right? So this is the strong OT hypothesis, is that all differences between phonological systems in the world's languages come from differences in constraint prioritization, not from restrictions on possible inputs or restrictions on possible outputs, not from having different constraints, but just from prioritizing the existing constraints differently. And this is the kind of radical optimality theory hypothesis. And what it says is that given a set of constraints, and of course finding the constraint set is going to be tough, but given a set of constraints, every ranking of those constraints is a possible language, and every possible language should correspond to at least one way of ranking the constraints that there are. So that is OT's vision of phonology, vision of typology. It's an extremely strong hypothesis. It's going to be extremely difficult to describe all the world's languages using only this one parameter that's allowed to differ. But it's worth investigating strong hypotheses because where they go wrong, we can learn things about what's wrong with the theory. If we start with a theory where, anything goes and languages just differ because they turn some features into some other features in some other context, then pretty much any set of phonological changes should be a language. And if we don't find all those languages out there, there's not really any way to figure out why or how the typology is being restricted. If instead we start with a really restrictive typology, then if we run into trouble, we can figure out how to make it less restrictive. So one way of talking about languages and phonologies in this framework is that we can talk about the entire language generated by a ranking. Right? Here we've looked at a specific input-output pair and a specific ranking and showed how that input-output pair maps, right? How this particular mapping works. But we could expand this to every other potential word in Maori and talk about the entire language that this ranking generates. So in the next page, I'm going to give you still an abbreviated illustration of what that might look like. But it's going to expand from just one input-output mapping to look at a whole bunch of them. And ideally, you'd want to actually look at every possible or relevant or difficult input-output mapping in a language and talk about the entire language that this ranking generates. Now, in practice, we're not usually going to analyze an entire language at a time. Instead, we're going to look at some systematic phenomena like, hey, what does Maori do with strident fricatives? Or, hey, what does Maori do with word final consonants? Right? And we're going to generally pick one phonological property or one phonological phenomenon and ask how a specific language patterns with regard to it, or how different languages pattern with regard to that specific phenomenon. So we could expand it beyond Maori and say, hey, how do different languages deal with input esh? Right? Some languages allow it, other languages don't. Amongst the languages that don't allow it, maybe they do a variety of different things to this sound. So we're generally going to be focused on one thing at a time, where by thing here I mean systematic phonological phenomenon. But in principle, the idea is that an OT grammar, which is just a constraint ranking, generates an entire language, not just specific word forms with specific properties, right? But any input will be mapped to elicit output. So here I'm illustrating this with, instead of one word, now we're using 8 words. And of course, this is still not an entire language, but it's just meant to show you the overall shape of how an OT grammar is supposed to work. So again, we start with this rich base where target forms are selected, and these are the inputs to the grammar. And here I've put 8 different potential inputs and a ranking that corresponds roughly to how Maori deals with strident fricatives. But in principle, this base is actually an infinite number of ill-formed and well-formed phonological objects, and we're looking at more than just stridency in the entire grammar. We're going to have constraints that deal with every phenomenon in every grammar. I've expanded it a little bit here to show you what that might look like in general. Of course, this is nowhere close to an entire language yet. It's 8 particular input forms. So here's some potential inputs. Some of these are well formed in Maori. It's a little bit hard to see probably on the screen capture, but we have some native Maori words here like haka that are perfectly well formed, and then some other potential Maori words like sake that are ill-formed in Maori, and then we also have some English forms like silk and sheep that are also ill-formed in Maori, and we're going to take a look at how any of these input forms can be mapped to an output given this constraint ranking. So in the next step, we've got our inputs here. Well, what are potential outputs? Again, pretty much anything is a potential output, but for any given input form, you can usually narrow this down to a fairly small set of relevant candidates. And here I've again used 3 candidates outputs for each input. Of course, in a real grammar, you'd probably need to consider more potential outputs, but just to illustrate, this will be enough. And again, it's kind of hard to see what's going on here. Let me zoom in a bit on just one of these. Yeah, so for input moa, what might you do with that? You might produce it faithfully as moa. You might change that initial consonant for some reason. You might change it to a v. You might change it to a sa. You might do all sorts of other things to this one. And we've just picked 3 at kind of random here to illustrate what's going on. Same thing for input sheep, which we've already looked at. You might choose to keep that initial consonant as a sh. You might change it to a t. You might change it to a h. You might do all sorts of other things. You might add a vowel at the end of this, or you might not. And any of those is going to be a potential candidate. I'm just illustrating with a couple candidates at a time here. And the idea is that you're going to do this for every potential input in a language. You're then going to go through your evaluation process, where again, for each constraint, for each candidate output, does that candidate output violate the constraint? And sometimes you're going to need to look at the relationship between input and output. Other times you're just going to need to look at the output for markedness constraints. And using this, we're going to figure out what's the predicted output for each input in this target language, right? And so in the end here, for these 8 input forms, we're going to end up with 8 outputs that are predicted to be the Maori outputs for these particular forms. And given this extremely artificial example with only 3 constraints and only 8 inputs and only 3 potential outputs, this is going to select Maori forms as outputs, right? So moa is going to map to moa, rimu to rimu, silk to hiraka, haka to haka, sheep to hipi, hui to hui, pui to pui, and sake to hake. This is how this particular toy example works, and indeed, all of these output forms correspond to actual or potential Maori words. Therefore, this grammar, which is really, again, just a fragment of a grammar, seems to be right to characterize Maori with regard to the specific forms that we've analyzed here. Right? So this is basically how OT works. A ranking is a grammar, and a ranking generates an entire language. And then we want those languages to be right. We want it to predict the languages that exist and not to predict languages that don't exist. Whereby languages here, what we're really talking about is phonological grammars, right? Systematic properties of sound systems that we do find or don't find across languages. So this is all very grandiose, and we're having to simplify a lot. And so what's the point of this? Oh, we got a plane going past, or a helicopter going past. Give me a minute. All right. Well, note that optimality theory is not a particularly easy tool for describing specific languages. Right? If we just want to describe, hey, how do fricatives work in Maori, an OT analysis is not the simplest or easiest to understand way of doing this. Right? In the extreme, you could say that describing any one thing in any one language requires us to know the set of universal constraints, and we can only really know that if we've analyzed every language that exists, right? Which of course we haven't. And of course, picking some particular ranking, in the case of dealing with one thing in one language, that's not much better or much insightful than just writing a rule that describes what's happening. Oh, and sorry, this is anachronistic. I should have taken this out. We're not doing the final paper this semester, but in general, when I have people do final projects, I don't ask you to use optimality theory in those projects because mostly you're going to be focused on one thing in one language, and it's not really feasible to try to get a full account of how those work in every single language and their typology. And in general, it's going to be easier to describe things just using this rule formalism. Well, plus strident plus continuant minus sonorant, right? So strident fricatives in Maori are predictably non-strident, right? Or something like that in the context of everywhere, right? That's a perfectly good description of what's going on in Maori. You don't need a universal constraint set and a rich base and potentially infinite output candidates in order to describe that, right? But the reason why we're using this complicated formalism in the class is that it's a very powerful tool for dealing with variation across languages. Because if the only differences between languages are constraint rankings, and we know the relevant constraints, we can predict what kinds of languages are possible and impossible languages. And that is a very, very strong set of predictions or hypotheses that can be tested against available data and can be shown to be right or wrong in different ways. Right? So it allows us a really principled approach to the typology of phonological systems in a way that we can't do using the rule formalism, right? The theory that, hey, every language has a set of specific language-specific rules, and they change some feature values into some other feature values, maybe in the context of yet another set of feature values. Well, that basically predicts that anything goes in terms of different languages, right? Maybe Maori maps sh to h, and somewhere else out there should be a language that maps sh to ah, or maybe there's a language that just deletes sh, but only if it's before a nasal consonant, and otherwise it, turns it into an implosive stop or something like that. You can write any of these rules within our rule formalism, and as a consequence, there's really no way to predict anything about typology, about how languages differ. They can differ in an infinite variety of ways, right, that don't necessarily have any connection to anything else outside the phonological formalism. And that's why I've introduced OT in this class. Even though it's sort of complicated and hard to wrap your head around, it allows us to actually approach cross-linguistic variation in a meaningful way. And other phonological frameworks don't do that. So in the next part of this handout, we're going to look at a concrete example of the range of languages predicted by a small constraint set with regard to one particular phonological phenomenon or phonological property. So in the Kocher chapter that I've assigned as reading in here, he goes through this for vowel nasality. And we've looked at this in English briefly earlier in the class as our example of complementary distribution or allophony. We saw in English that vowels tend to be nasal before a nasal consonant, but oral elsewhere. And so Kocher fleshes out how that might work in different languages, and looking at all the different kinds of distributions that we've discussed in this class, right? So we've looked at 4 kinds of phonological distributions, which are basically invariant inventory restrictions. You never find this value of the feature or this combination of values. They are free contrast, where the feature is contrastive. You find either value in any context, and it's lexically listed and unpredictable and contrastive. And then we looked at 2 variable patterns, allophony, which I just described, where it's not contrastive but varies by context, as well as positional neutralization, where also the feature varies by context, but it's unpredictable and contrastive in one context, and predictable and non-contrastive in some other context. Those are our 4 phonological distributions, and Kocher goes through this for vowel nasality in different contexts. That discussion is very detailed and good. That's why I've assigned it. But I think that the empirical facts supporting that typology are kind of weak. And so I'm going to use a different example, although I will go through that cocktail typology in the last video for this week. But it's in any case, it's good to get more than one example. And so we're going to look at a different phenomenon, and that's going to be the subject of the next video here.